Hello guys, it's the Caribbean Bookworm, and today I have a question for you, and that is, how many unique books do you think there are on this planet? Of course, that's a very big question, but let me specify it a bit further for you. By uniqueness, I mean, how many books do you think there are of one particular title? They can have different editions and different translations, but they don't have any copies, just that one title, but they can have different editions and different translations. How many do you think there are? About 100 million? About a billion amounts of books? Or about the 100 billion? Or maybe perhaps even a Google amount of books? A Google would be one with 100 zeros after it. So a huge, basically, amount of books. The larger the number, the more unintuitive it becomes to actually picture this quantity of things, and this is something which I wanted to express with this video, but by using books as an analogy. The question of which I asked initially is very crucial for this, because as I did a little bit of digging, not that much, but just a little bit, I found that some people actually had the patience to answer and tackle this question. As of 2010, a couple of data analysis from Google actually found an answer to this, and back then, at least, what they found, of course this number changes, they found this amount to be 1.2986 times 10 to the 8 amount of books. And to put that into perspective, that is 129.86 million books, which is a lot of books, unique books. The manner in which they did this is a bit technical. They looked at the serial numbers of the books instead of looking at the ISBN number, and they looked at this for unique books, different versions of the books, and they used a software in order to process this amount of books for every data bank that there were around the world with books, and in that way kind of quantify the amount of books that there were back then. But of course, this number changes as books are constantly being archived. So new books are constantly being archived, or old books are constantly being discovered and then archived within our data bank. So of course this number continues to grow, and who knows how big this number is now in 2021 as 11 years passed. Perhaps you can do the math on that one, and you can do the calculations and use your fancy software to figure that out. But the point is not to figure that out here. The point now is to look at the number. That number is actually unfathomably huge, because that number happens to be very close to another important number that is related to something more cosmic. Say right now that the electricity were to go off wherever you are, or perhaps that you were walking in the field right now or in a park and you were seeing the night sky. Once you're seeing the night sky, once you're more exposed to the darkness, your pupils dilate in order to gather more light, in order for you to see things more clearly and not bump yourself everywhere that you walk around. As a consequence, if you're looking up, if you're stargazing, you're going to start seeing more and more stars, basically, as your eyes adjust to this pitch black darkness, basically. And as you see more stars, besides seeing these beautiful twinkling lights in the sky, perhaps you might also see this very interesting band. This band that is very bright in certain areas, yet very dim in other areas. But it's a very narrow, thick band that you see that stretches actually across the night sky. And if you stargaze before, you'd recognize this to be the Milky Way, and you'd be correct. And the Milky Way is our local galaxy. It's the galaxy in which our solar system, which the Earth is a part of, our sun and planets, the solar system revolves around our galactic center along with a lot of other stars. And the revolution time for this orbit around the Milky Way, for us humans at least, would be almost infinitely large, but on the cosmic scale it would be almost irrelevant, since there is also other huge timescales in the cosmos. But case in point, we are part of this very large collection of stars, you could say, that are orbiting a galactic center. And as of 2017 to early 2018, the European Space Agency, which is a bit like Europe's response to NASA, they had a survey done, and they managed to have an approximation for the amount of stars within the Milky Way. Of course, this is an approximation, so not an exact answer, as there is always better techniques you could use to do these types of measurements. They found an approximation of the amount of stars stars in the Milky Way, which turned out to be about 1.9 times 10 to the 9 stars. This is 1.9 billion stars within the Milky Way, which is just shy of a factor of 10 from the amount of books that Google managed to find back in 2010. So they found a number that was 10 to the 8, and basically the amount of stars in the Milky Way is just 10 to the 9. So in a nutshell, if we were back in 2010 and you have this amount of books that Google found, if you were to times this by 10, then you would have more books than you would have stars in the Milky Way galaxy potentially. Now, does this mean basically that we have more books than the amount of stars in the Milky Way galaxy? Potentially yes, potentially no. But what I mean by this is it may turn out that there are many more stars than what I've mentioned here, and that it just requires a bit more of a finer technique in order to identify these stars, or maybe they're more dim, maybe they're further away from us, etc., etc. Many factors play a role into this, but there is also the chance that we do already have more books than the amount of stars in the Milky Way if we go by the two numbers we mentioned. That has to do with our initial question. If we just tweak that just by a slight margin, then we can actually find an answer that is perhaps closer to the number of stars or even bigger. And that tweaking has to do with what we mentioned about uniqueness. If we disregard that uniqueness factor, if we say what are the amounts of books there are on planet Earth, then I think we would have a much larger number, because for every book there are a lot of copies of that exact book, for that exact book in different translations, for that exact book in different editions and volumes. So you would have a significantly bigger number than that which Google mentioned, since they didn't take that into account. And if you take that into account, you would have this humongously big number for the amounts of books that there are, which would make sense too. You've been to a local library, you've been to a local bookstore, and you've noticed how many books there are. You could probably not count them on your hand because there are a lot. So they're probably around the something thousand mark, or perhaps even more. And that is just one bookstore or one library. And depending on where you are, you could have more libraries or more bookstores. And that is just your local area, but you could be in a whole country that is very big, meaning that there are more bookstores and more local libraries, or more libraries in general in that country. You live within a particular continent, and that continent has various countries, and you have 7 continents on the planet and 6 which are very widely populated, so you have again more options for books. And thus the number continues to pile up. And the reason why I want to point this out, and the little cosmic fact, is because something that you can notice here is, as we went up to scale, it became a bit easier to imagine the numbers, I imagine, right? It's a bit easier to imagine 7 continents as it is to imagine thousands of books within your local library. And one clever trick which people do to kind of solve this problem, they basically use reference points for measurements. For example, within astronomy, since you're dealing with very large distances, instead of talking about, say, meters or kilometers such as we usually do in our day-to-day life, they would talk about light years, since stars aren't within that meter mark. Stars are about, say, a billion kilometers away from us and even more. So they would talk about something like 3.1 light years. But if you go on to the smaller scales and numbers, you can also use reference points in order to facilitate your expression for something. For example, if you're running on a treadmill, it's much easier to define how much energy you're burning in terms of calories. Say you're burning 400 calories by running on a treadmill, even though that's a lot of calories, so good on you. Say if you weren't burning any calories, or say if you're talking about an electron, a really small point-like particle that is moving throughout something. Just one electron has a very small energy, even if that energy may be extremely large from its from its reference point. Basically, it's still a really small energy for us. We wouldn't be seeing that the electron has particular calories when it's moving, because that would make it quite inconvenient, as we would get a relatively small number. But we would say that the electron is moving with a particular electron volt, or that it entails a particular electron volt as its internal energy, because that makes it much easier, or gives you numbers that are much easier to work with, instead of working with these in terms of calories or joules for energy in this sense. So people do try to solve this problem by assigning different reference points, and in that sense you can still work with very big or very small numbers. And that is quite unique and fascinating. This is also the mark in which I want to end the video on, or the note. But I do have one final question for you, and it is more of a mathematics question for those of you who are curious or just like numbers. What do you think would be the largest number that man has basically added a name to? I personally think it might be Shannon's number, which is 10 to the 120, and it's basically the number of possible chess combinations that a mathematician has found to be possible. Or it might be a Googleplex, which is 10 to the power of 10 to the power of 100, which is basically 10 to the power of a Google. A ridiculously huge number. But if you happen to have an idea of this, or just one that you think in general might be a really big number that someone has named, name it down in the comments down below, and also let me know what you thought of this video idea. If you want to see more of the video of the like, please let me know in the comments down below. I will gladly think of some to deliver. Hope to see you guys soon, and bye.